Hello everyone and welcome to another episode on this very channel. We are still on linear operators. If you haven't yet subscribed to the channel, kindly hit on the subscribe button for me. If you could remember in our previous lesson on linear operators, I said that if you have linear differential operators with constant coefficients, then the commutative property of multiplication holds. When you have linear differential operators with constant coefficients, then the commutative property of multiplication holds. This is what I mean. Let's take it that you have an operator M, and this operator is defined as 2 del x minus, let's say, 3 del y. And then you also have another operator L, and this operator is defined as del x plus, let's say, 4 del y. So we can see that these two operators M and L are having constant coefficients. So the coefficient here is 2, the coefficient here is 3. With L, the coefficient is 1. With this side, the coefficient is 4. So we are saying that if you have linear differential operators with constant coefficient like this, then these two operators will commute. So we can say that operating L on M will be the same as operating M. So this means that when you have two linear differential operators with constant coefficients, the commutative property will hold. But when these two linear differential operators are having variable coefficients, so it means that let's claim the constant and then replace them with what? Variables. So let's say x and then y, let's say y. So you can see that these two linear differential operators are having variable coefficients. And when they have variable coefficients, then the commutative property of multiplication will not hold. So operating L on M will not be the same as operating M on L when the operators are having variable coefficient. And that is what we want to look at in today's lesson. So let's look at the example on the board. So this is the example that I want to look at. Given that L and M are operators and M is defined as that, and then operator L is defined as this. We want to show that operating L on MU will be the same as operating M on LU. This is what we want to look at. So first of all, we have to know our function. So we are going to let U be the function, and U is in terms of what? X and Y. So U be the function. And then M and L be the what? Operators. So first we have to find our MU. So we have M operating on what? U. That is going to give us what? MU. So MU, we are going to have this M. So we have 2 del x. Then we have our U. Then we have minus del y. We have what? Our U. That is MU. Then we move on to LU. We find LU. So we have L operating on the function U. So where is L? So this is L. So we have del x. We have our U plus 4 del U del y. So this is our MU and this is what? Our LU. Now let's start with the left hand side. Where is it? LMU. So we have LMU. That is L operating on what? MU. We are starting with that first. So L operating on MU means we are going to take the operator and then we put it on mu. So where is the operator L? The operator L is this. So we are going to write it. So we have del x plus 4 del y operating on mu. So this is mu. We are going to have 2 del u del x minus del u del y. So once you have this, we are just going to apply the distributive property. So this is going to multiply what is in the bracket. This is also going to multiply what is in the second bracket. So we are going to have del x multiplying 2 del u del x minus del u del y. Then we take the second term to also multiply the second bracket. 4 del y multiplying 2 del u del x minus del u del y. I guess you are following. Now, what we are seeing here is not direct multiplication. Please don't say it is multiplication. Del u multiplying 2 del u del x. Please now. Now, what this means is that we are going to differentiate what is in the bracket here with respect to x. This is del x. We are going to do what? Differentiate what is in the bracket here with respect to x. So let's continue. So when we differentiate del u del x with respect to x, we are going to have the 2 is a constant. So we are just going to repeat it. We are going to get del square u del x squared. Now when we differentiate this function with respect to x, we are going to get del square u del x del y. I guess you are following. So we are done with this. Let's move on to that. We are going to differentiate what is in the bracket here with respect to y. Now 4 is a constant, so we have 4 times 2 give us 8. Now when we differentiate del u del y with respect to y, sorry, del u del x with respect to y, we are going to get del square u del x del y. Then move on to the last function. We are differentiating del u del y with respect to y. So we have 4 is a constant, so we have 4 del square u del y square. Very, very easy and then simple. Let's continue from the top here. So for me, we are just going to group like them. Those with the x, the y, the x, the y go to one side, then the square, the x square, and then the y square also go to another side, grouping the like terms. So we are going to have 2 the square u the x squared. Then you come and pick 4 the square u the y squared. So we have minus 4 the square u the y squared. Then we have the x, the y, the x, the y. So we have plus 8 the square u the what? The x, the y minus the square u the x, the y. We have the square u the x, the y. So we are going to have 2 the square u the square u the x squared minus 4 the square u the y squared. Now we can factorize the square u the x the y, right? So that we have 8 minus 1. That is giving us what? 7. So I can make it 7 and then bring the 7 in front. Good. So it means that what is here is equal to what? LMU. So we have the whole of this is LMU. Now once we are done with LMU, we are going to move on to, where is it? MLU. MLU. To see that what we are going to get is going to be the same as this or not. So let's move on to M operating on L and then U. So we have M LU. So first we are going to take the operator M. So where is the operator? This is the operator M. So we have 2 del X minus del Y operating on LU. Where is LU? So this is LU. We have del U del X plus 4 del U del Y. Now we are just going to apply the distributive property. This will multiply the second bracket. This will also multiply the second bracket. So we are going to have 2 del X multiplying the whole of this. We have del U del X plus 4 del U del Y. Then we have minus del Y multiplying the second bracket. Del U del X plus 4 del U del Y. Very, very interesting. So as I said, this is not mere multiplication. We are not just going to multiply this. We are going to differentiate what is in the bracket with respect to S, differentiate what is in the bracket with respect to Y. Very good. So we have 2 here. So the 2 is a constant, so we have 2. When we differentiate del U del X with respect to X, we are going to get del square U del X squared. So we have del square U del X squared. Very interesting, very, very interesting. Then we have 2 times 4 give us what? 8. You multiply the constant 2 times 4. It will give us 8. Then we differentiate del U del Y with respect to X. And that's going to give us del square U del X del Y. So we are done with this. We move on to this side. So we have our minus. We are differentiating del U del X with respect to Y. So we are going to get del square U del X del Y. Then we have minus 4. Differentiating del U del Y with respect to Y, we are going to get del square U del what? Y squared. So from here, we are just going to group the like terms. So we are going to have 2 del square U del X. Then we have minus 4 del square U del Y squared. Then we have del square U del X del Y, del square U del X del Y. So we have, when we factor del square U del X del Y out, we will have it 8 minus 1. So we have 8 minus 1. That gives us what? 7. So I can decide to bring the 7 in front to have this. So what we have gotten is what? M operating on LU. So let's compare the terms and see. So the first one, we have 2 del square U del X squared. We have 2 del square U del X squared, sorry. And then we have minus 4 del square U del Y squared plus 7 del square U del Y squared. So we can see that the terms in MLU are the same as the term in LMU. So that is why we are saying that when you have 2 linear operators with a constant coefficient, then the commutative property holds for that linear differential operator. So we can say that LMU is equal to MLU. Very, very easy and then simple. So conclusion, you can say that LMU is equal to MLU. Very, very easy and then simple. Let's look at linear operators with variable coefficient. With what? Variable coefficients.